Now let's look at learning objectives D and E, where we're going to determine if a relation is a function using either mapping or a vertical line test, and then we'll talk about domains and ranges of particular equations. So let's first just look at a relation. These two are both considered relations because they're just sets of ordered pairs. And let's talk about how can we tell if a relation is a function. If you're given a set of ordered pairs, here's how you tell. In each, the first component x is paired with exactly one second component of y. So for every x value that is unique in the data set, there can be only one unique y. So if we look at the relation called f, when they put in the number 1, they get a unique answer of 2. When they put in 2, they get 4. When they put in 3, they get 7. Okay. Now let's look at g. When they put in 1, they get a unique answer of 2. They put in 2, a unique answer of 4. But they put 1 in again. Did they get a unique answer of what should be 2? Because that's what we said back here. Here we said when you put in 1, you should get 2. But this time they put in 1 and they got 7. So based on this, letter F is the only one that meets the function requirements. Relation G does not. Now let's look over here at relation H. Let's talk about first, is relation H a function? So every time they put in 5, they get the answer 1. When they put in 6, they get the answer 3. But wait a second here, when they put in 7, they get the answer 1. So what you have to question yourself, is this right here a problem? Well, again, the definition says for every x, there's exactly only one unique y. Well, on here, the x's are 5, 6, 7, and 8. They never put in one of those numbers a second time and get a different answer, as they did back up here when they put in 1 2 different times, they got 2 different answers. This up here is not good. This right here is absolutely fine. They all can actually go to the exact same y output. It doesn't matter. What matters is that every time I put in 5, I get the same answer. So yes, this is a function. Fine. What is its domain and range? Well, to find the domain, remember, domain means all the x's or the inputs. Range means all the y's or the outputs. If it helps you, it's alphabetical. D comes before R as X comes before Y. That's how I remember. To state the domain on ordered pairs, you're going to use a set notation, and you're going to put them in increasing order with no repeats. So the X values are 5, 6, 7, and 8. The ranges work the same way. I'm going to use set notation. I put them in increasing order with no repeats, so the range on this, all the Y values, are just the numbers 1 and 3. Well, here's a second definition of a function. They mean the same thing, but let me read it to you. A function is a correspondence between two sets, A and B. Maybe we're even thinking X and Y as in the ordered pairs, in which each element in A corresponds to only one element in B. Well, that means the same thing that we just said about ordered pairs. For every unique X, there has to be the exact same Y answer. If X goes to a different answer, then we have an issue and it's not a function. Before we continue on with functions, we need to talk about a little bit of vocabulary, what real functions are. Real functions are functions whose domain and range is a set of all real numbers. And what real numbers are, if you want to write math shorthand, you can. Looks like this. It's a capital R, and there's like a slash right there on the side. It's a really nice math shorthand for that. So let's talk about what these other numbers are, though, because they kind of roll into real numbers. So real numbers are our family of basically all of our numbers out there. So these are all the reals. Now, what's inside of those are different types of numbers. The most basic of those are the natural numbers, which you learned back in grade school. So the natural numbers is this capital N. Those are their numbers like 0, 1, 2, 3, and so forth. So the positive whole numbers. Then after the natural numbers, The next group would be the integers. So the integers come into play, and that's a capital Z. And what the integers are all the natural numbers, so 0 and the positive whole numbers, plus the negative whole numbers, and so forth. So that's the Z here. And then the next one are the rational numbers. So the rational numbers are also then embedded in here. And they're going to use the letter Q for that. And the rational numbers include all the natural numbers. They include all the integers, but then they also include numbers such as fractions. So 1/4, 2/3, things that can be written as fractions. And then again, to cap it back off, all of those roll under kind of the umbrella of the real numbers. So the real numbers again are the natural counting numbers, the negative whole numbers, the fraction numbers, and the other unique thing those include would be like other real numbers would be pi or the square root of 2 or a decimal that has no repeating pattern to it, something of that nature. Now the other notation you might see in this book is a member or an element of, and here's what it is. If X is said to be in set A, for example, they would write it like this. They would say X is an element of set A, and that can mean anything. They might say X is the number 0.2, which is in the set of real numbers because it's considered real. Okay, let's continue on with the functions again. So we talked about the definition of function. For every X, there's exactly one unique Y, but there's a visual way you can tell if you have a function. If you remember, it was called the vertical line test. And all you have to do is this, is you graph the function. In particular, if I graph this right here is going to be a parabola. If I put it on my graphing calculator, is going to look something like this shape here. And they're going to say, is this a function? Well, if it passes a vertical line test, meaning if I draw all the possible vertical lines anywhere on this graph, it can only cross in one spot. If it crosses any more than one spot, it will fail the vertical line test and will not be a function. This is fine. So is this one a function? Yes, it's a function. Okay. This graph right here, let's sketch that and see if it's a function. I will tell you if you put that in your graphing calculator, it's going to look something like that. Well, this one, if we do the vertical line test, you draw a vertical line here, 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 wherever, it's going to pass every vertical line test. So here, yes, this is also a function. So let's go to the next step. If it's a function, state the domain and the range. Again, remember, domain means what can the x's be, range means what can the y's be. So for the domain, the best answer to say is all real numbers. And I'm going to abbreviate that. I'm going to do all real numbers, a little math shorthand. Except, or greater than, or less than. And here's what you're going to ask yourself. Is there a value if you put it in for x, you cannot mathematically compute it? Can you put in something like -1, +1? Can you put 1/2, the square root of 2? Are there any issues? You can tell if there's issues if you look at your graph. If you see a break in the graph where you literally had to lift up your pencil to draw it, then you have a domain issue. There's no domain issue here, so the domain is all real numbers. Everything works for x. Okay, the range is the y's. So the y-axis goes up and down. I think the easiest way to look at the range is just travel along the y-axis, keep going until you see the activity actually start. This blue graph doesn't actually start until right here on the y-axis, which is at -4. Then you start seeing more of the graph drawn. So the range on here is going to be all the y values that are either greater than or equal to -4 is what the y's can be. Okay, let's switch to the next one. What is the domain and the range of this happens to be an exponential growth function? Well, let's use my comment before about the domain. Again, the domain is the x-axis, so as you travel along the x-axis, your eyes are going left to right. Do you see a break in this graph anywhere? Did the person ever have to lift up their pencil to draw it? No, it was perfectly fine. There were absolutely no issues. So the domain for this function is all real numbers. any x works. Now the range, again, for the range, we're looking at the y-axis. So as if I'm coming up the y-axis from the bottom, there is no activity in the negative y's. I don't see any y activity until I cross over the origin, and then I start seeing the graph. This graph does not start until the y's are greater than 0. Now this one you cannot have equal to 0 because what happens for this exponential function is actually hitting an asymptote, which is an imaginary horizontal line that it's approaching, but it's never going to cross. Let's look at another one for domain and range. So here we have another graph. This does happen to be exponential. Here's the equation, and it's been graphed for us to find the domain and the range. So again, for the domain, as you look at it, and when this graph was drawn, it's a very smooth graph. It continues on here. I don't have to lift up my pencil. I have no issues. There's no breaks in it. Also, as you travel along this x-axis, as I look down below this black line, there's graph activity. There's graph activity as I travel along the x-axis the entire time. There's never not graph activity. So the domain here, again, is all real numbers. Everything works just fine. Now the range just means the y's. So as I travel on the y-axis, there's nothing down here by -6 or -5 or -4s when it's starting. So here it starts right at -4, and then it continues on. As I travel, I still see blue graph. So the range on this, or all the y's, be careful. If you do graph this in more detail, it's the y is greater than -4. It actually does not include -4 because this graph does have an asymptote that it approaches but never crosses.